So, hello students, how are you? So, this video is basically explaining how you can use this software named Fusion 360 to understand the idea of surface area and volume of different objects. Different objects means cube, sorry, not cube, cone, sphere, hemisphere. How you can use the software Fusion 360 to understand how you can calculate the volume with the help of the virtual models so that you can easily understand the concept of the calculation of surface area and volume. So let's start. So this video, my main focus is the surface area and volume of three objects such as cone, sphere, and a hemisphere. Okay, so let's start with a simple example. This software is what is called a Fusion 360. This is a free software. For students, this software is free to download. You can create an account in Autodesk, similar to the Gmail account creation, So you have to enter your details, your name, your details, your school, everything, or university, everything. Then after that, the Autodesk will give you 3-year license so that you can easily use it. So the schools, universities, everywhere, those who are interested in implementing this software, I am ready to help. So this video is basically focusing schools, those who are interested in implementing this software to their curriculum. So for this video is basically dealing with how teachers or students can use Autodesk Fusion 360 to explain the concept of surface area and volume of three different objects such as cone, sphere, and hemisphere, right? So I will start with one simple example. I will start with a cone. So first of all, I am going to create a cone with the given dimensions. So the given dimensions are, say, for example, the given dimensions are slant height is 10 centimeter. So I will draw a triangle. Okay. Okay. Yeah, let's take the question. Yeah, the slant height is 10 centimeter. So slant height, what is the slant height? So consider this right angle triangle. This line, this slant line, this represents the slant height. So the slant height is 10 centimeter. That means 10 centimeter means 100 millimeter, right? And the radius. So this baseline, this is what is called radius, and this radius is 7 centimeter. That means 70 millimeter. So this is a triangle. This is a triangle with radius 77 centimeter or 70 millimeter, and the slant height is 10 centimeter. Okay, so just moving this. Yeah, okay. So finish sketch, and then I will select a command called revolve, and then I have created a cone. Okay, so this is a cone with radius 7 centimeter and the slant height is 10 centimeter. So we have to calculate the CSA, curved surface area. So when the students is creating this cone in front of this computer, in the computer in front of that student, he can easily understand while rotating this cone. He can see which one is the base, which one is the curved surface. So this is what is called, this is the curved surface, curved CS. So this area is what is called a CSA, right? This area is called a CSA, and this bottom portion is called a base, right? So the question is how we can calculate the CSA, how we can calculate the curved surface area of a cone. So we know the equation. What is the equation? It is pi r L. So pi r L means pi, what is the value of pi? 3.14 or 22 by 7, right? So 22 by 7 into what is the radius? Radius is 7 centimeter into or 70 millimeter into the length. Slant height is 10 centimeter or 100 millimeter. Then after that, the students can calculate TSA manually, right? So TSA is equal to CSA. What is the equation? CSA plus base area. What is the area of the base? It is pi r square. So it is pi r square. So the TSA, the total surface area of a cone, is pi rl plus pi r square. Pi rl plus pi r square. So this is the total surface area of this cone. So in the software, they can easily check, inspect. They can easily inspect. Say for example, click this. When I click this, you can see. Okay, so I'm clicking this inspect measure. So click this. So this area is displayed here, right? So what is the area? 21991.149 mm square, right? So that is the area. So it can easily. So click this, select the body. Go to inspect measure. Okay. So in this way, the students can calculate what is the area of the base. So this here you can see selection 1. This is the area, and it is displayed here. 1539.3.804 millimeter square, because this unit is in millimeter, right? So we can change the unit here. Let me check. Is in, yeah, centimeter we can change. Okay. So go to inspect measure. So now what is the area? 153.938 centimeter square, right? Or you can calculate, the students can calculate the area, CSA, curved surface area. So what is the curved surface area? 219.911 centimeter square. When the students calculate it manually, that is the equation pi RL. So the area is same, exactly same. When I calculate pi RL, pi into R into L in centimeter, it is it is rounded to 220 centimeter square. So in this way, students can calculate manually the area, and they can check. They can create the 3D model, and they can click the different areas, such as which one is the curved surface area, which one is the base area, so that they can easily understand the concept of area and volume easily with the help of this Autodesk Fusion 360 software. Okay, so So from this figure, what is the area? The area is 219.911 centimeter square. So this area is rounded to. So this is the CSA actually. This is the curved surface area. So this area is rounded to 220 220 centimeter square. So if the student calculated this manually using the equation pi into r into L, he will get the same value, 220 centimeter square. So when a student is practicing this in his class, or when a teacher is guiding the students to create this cone and then calculate the curved surface area manually and check what is the area he is getting in the software, so that the student can compare the area he is getting using manual calculation and also in the software calculation. So he will confirm that both are same. And also while creating this shape, he will be learning the shapes in different levels, right? Such as for example, for example, what is this which one is the slant height, which one is the radius, and what is the how we can calculate the dimensions. For example, take the sketch again. Take the sketch again, edit sketch. So this represents the slant height. So the slant height is, sorry, the slant height is 10 centimeter and the radius is 7 centimeter. So students can easily understand the concept of surface area and volume. So after solving some problems, I will explain the volume also. So doing these types of problems in with the help of Fusion 360 software, the students can easily understand. So their learning, the learning level will be very different when the student is using this particular Autodesk Fusion 360 software. So this is one example, and I will give you another example. I will take another example. I'm closing this. Okay, I'm not closing. I'm just creating a new tab. So click this plus option. So the first model is already here. I'm not closing this. Here there is a plus option. When you click, I'm getting a new tab. So next time I'm going to create another cone, and I'm calculating and I'm calculating the curved surface area and the total surface area of the cone. So here in this again, I am going to draw a right angle triangle. So this is my right angle triangle. And so before that, I'm changing the unit, and I'm changing the unit to centimeter. Okay, now the unit is in millimeter. I'm changing this to centimeter. And then the height of the cone is 16 centimeter. So the height is 16 centimeter. So this represents the height of the cone and the base radius. So this line represents the base radius. It's 12. Sorry, it's 12. So it's 12. Okay. Okay. So the height of this cone is 16 centimeter and the radius is 12 centimeter. Okay. We have to calculate the CSA and the TSA. That means curved surface area and the total surface area. So right now I'm finishing the sketch and I'm revolving this. Go to revolve command and click the center line. Click OK. Okay. Now this is my cone, right? I'm adding a different color. So I'm taking wood so that we can see in a different color. Okay, not this. Yeah, I will take this color. Okay. Yeah. Okay, no, this one is good. Okay. So this is my cone. So this is my cone with the height is equal to 16 centimeter and the radius is 12 centimeter. I'm going to calculate the CSA, curved surface area. So manual calculation, what is the equation? It is pi RL. Pi RL is the equation to calculate the CSA of the cone. So go to inspect in the software. You can go to the inspect, click measure and click this curved surface. And we will get the curved surface area is displayed here. And what is the area? 753.982. Okay. So when I calculate this using the equation pi RL, I will get the same value, 753.982. When I use pi into R into L, the answer will be 753.982. You can check. Then go to inspect. I am calculating the area of the base. It is 452.389. Okay, so this area, how you will calculate this area? This is circle and this equation is pi r square. This area you can calculate with the help of the equation pi r square. Pi r square. So when you add these two areas, you will get the total surface area. Okay, so the area of the base is 452.389, whereas the curved surface area, is 753.982. So when you add these two values, you will get the total surface area. After doing the manual calculation, students can check is this area, software area, and the manual calculated area is same or not. If it is not same, the teacher should tell the student to recalculate the equation, resolve the problem again, check the steps, any problem or any issues, so the teacher can check and make sure that both software value and the manual calculated value are same. So in this way, students can parallelly use manual calculation and software usage, so that their learning level will be we can increase the learning level of the students. So in this way, the teacher can engage the students more than traditional level of teaching with the help of this particular software. Okay, so that's all about the area of cone. Then we will see the area of sphere. Next, we will see the area of sphere. Okay. So I'm closing this. I am creating a new tab. Okay. First of all, what is the how you will calculate the area of a sphere? Sphere means sphere. There is only one area. Both sphere surface area means both total surface area and curved surface area both are same. So the surface area of the sphere is 4 pi r square. So now I'm going to draw a sphere of radius 7 centimeter. So I am selecting the sketch. So I am going to draw an arc. Okay. First I will draw a line like this. So before that I have to change the unit to centimeter, right? Because the radius is 7 centimeter. So I'm changing the unit to 7 centimeter, centimeter. Now the unit is in centimeter. Then I will change this to 7. So now the radius is 7. Okay. Next I'm going to uh, draw an arc. Okay, where is arc? Okay, center point arc. Okay, this is the center. Okay, draw an arc like this. Similarly, I will draw another arc. Again, go to create arc, center point arc. Okay, then I will join these two line arc endpoints using a straight line. Now this half portion is ready. Then I am selecting the trim command and then I am deleting this line. Okay. Then finish sketch. Now I'm going to revolve this. Okay, so this is my sphere. Now I got a sphere. So when the student is creating this type of shapes, they will be very much interested in this particular subject and this particular topic, and they are very much involved. They will be doing so many things. So they will be creating this type of spheres. They will be adding different colors so that their interest to this particular subject will be increased, will be improved. So this is a very nice way to improve the learning, improve the interest of the students to this particular subject. So, most of the students are not interested in learning mathematics, right? So while using this particular software, by creating this type of shapes and checking the area and volume, they will be very much interested to learn this particular subject in a different way. So this type of new techniques should be implemented than the traditional type of teaching technology or teaching methods. So now this is the sphere, and the radius of the sphere is 7 centimeter. So right now I'm calculating the area of the sphere. So using manually, we can calculate the area. So the equation to calculate the area of the sphere, surface area of the sphere, is 4 pi r square, right? So with radius r, so this is a sphere of radius r, and the surface area, we can easily calculate the surface area of the sphere using the equation 4 pi r square. So when I calculate the surface area of the sphere using the equation 4 pi r square, so the answer is 616 centimeter square. Okay, so I will write the value here, 616 centimeter square. 616 centimeter square. So this is the area of the sphere. Let me check. Go to inspect, then measure, and click this and check. See this. So both are same, right? So the area is 615.752 centimeter square. So that means if I round this value, I will get 616. 616 centimeter square. So both are same. So the students calculate the area manually, and they will check the area displayed in the software. So this is very interesting. This is really interesting. Then next I'm calculating the surface area of hemisphere. So what do you mean by hemisphere? Hemisphere means half of the sphere, right? So I'm going to create a new tab. Okay, so I'm creating a hemisphere, and the radius of the hemisphere is, say, 21 centimeter. First of all, I'm changing the unit. I'm changing the unit to centimeter. Click OK. And then I will draw a line like this. Okay. So this is the radius. What is the radius of this hemisphere? It's 21 centimeter. So the radius of the hemisphere is 21 centimeter. Now this is the radius. Okay. Next, I'm going to draw an arc by taking the center point arc. This is the center, and this will be the radius. Draw an arc till here. Okay. Then I will join this line with this point. Then go to finish sketch. Then revolve command. Click the center line. I'm getting the hemisphere. Hemisphere means half of the sphere, right? So hemisphere means half of the sphere. So how you will calculate the area? So in hemisphere, there is one curved surface. So that means there is a curved surface area, and there is a circle. That means there is a total surface area. Total surface area means curved surface area plus this area of the circle. That is what is called a total surface area. So this area is pi r square. We already know that. And what is the surface curved surface area of the sphere? The surface area of the hemisphere is 4 pi r square. So hemisphere means half of the sphere. So that means divided by 2. So 4 pi r square divided by 2 is 2 pi r square. So 2 pi r square is the curved surface area, and the total surface area will be 2 pi r square plus pi r square. That will be 3 pi r square. Okay, so next I'm going to calculate the curved surface area and total surface area of this hemisphere. First I'm going to calculate the curved surface area. Go to inspect, measure, click this surface. I'm getting the curved surface area. It is 2770.885. Okay, if I'm using the equation, that is, what is the equation to calculate the curved surface area of hemisphere? It is 2 pi r square. So 2 pi r square, when I use the equation 2 pi r square, I'm getting the same value. I'm getting the same value, 2770.885. So this value is rounded to, I can take rounded to 2771 centimeter square. Then after that, the students can calculate the area of the circle. So again, go to inspect, measure, click this surface. So the area is 1385. So uh, uh, add this area plus curved surface area, then the student will get the total surface area. So when I add these two, I will get the total surface area is 4158. Okay, so I'm taking the calculator. I will show you. Okay, so this is 1385. So I will, okay, wait, 1385 plus 1385 plus. So what is the curved surface area? 2770.885. So plus 2770 plus 2770. That will be, so the total surface area will be 4155. So in this way, the students can easily learn the the surface area of different objects such as cone with a different radius, sphere, and hemisphere, right? Okay. So there is another option. There is another option that is next I will show you the volume. How you can calculate the volume. Okay, how you can calculate the volume of different objects. So now we have finished cone, sphere, and hemisphere, how you can calculate the surface area using the mathematical equations, and how you can check those values in the software, right? Next, we are going to calculate the volume. First of all, how you can calculate the volume of a cone. Okay, so I will draw a cone. I will draw a cone. So next I'm going to change the unit to centimeter. So now the unit is in centimeter, right? So I will draw a triangle first, right angle triangle. So this is the right angle triangle, right? And the given dimensions are the height. Height of the cone is 21 centimeter. Height of the cone is 21 centimeter. The height of the cone is 21 centimeter. And the slant height means this is the slant height. And this is slant height is 28 centimeter, 28 centimeter. So the height of this cone is 21 and the slant height is 28. Next, I'm going to revolve it so that we will get the cone. Click the middle line as the rotation center line. Now the cone is ready. Okay. Next, I'm going to calculate the volume. We know that what is the volume of cone? 1 by 3 pi r square h, right? So the students can calculate manually what is the value of cone with this height and this slant height. So when I use the mathematical equation, I will get the value. So the volume. So the volume of the cone is 7546 centimeter cube. Centimeter cube. Okay. So what is the equation? How you will calculate the equation? 1 by 3 pi r square h. 1 by 3 pi r square h. So this is the equation to calculate the volume of the cone. Then we can check this value in the software. How we can check this value? So go to bodies, this one. Go to bodies, body 1. This body 1 is this cone. Right click and there's an option called properties. Okay, right click the properties. And when I right click this, you can see there is an option called the volume, right? So what is the check? What is the volume? Check what is the volume. It is 7542.964. So both are approximately same, right? So in this way, the students can compare the value of volume calculation using manually. So this is the manual calculation by substituting the value of R and H in this equation, and also they can check what is the volume he will be getting using this particular software. Now the volume of this cone is 7542.964 in the software, whereas in the manual calculation, the student is getting the volume as 7546 centimeter cube. So in this way, student can compare their manual calculation with the software calculation. So this is in this way, the student can find the volume of cone, right? Then next we can calculate the volume of sphere. So how students can calculate the volume of sphere? First of all, what is the equation to calculate the volume of sphere? It is 4 by 3 pi r cube. Volume of sphere is 4 by 3 pi r cube. So where r is the radius of the sphere. So now I'm going to create a new sphere. Go to sketch. I am going to select the front plane. Then first I will change the unit to centimeter. Now the unit is in millimeter. Now I'm changing this unit to centimeter. Okay. And then I will draw the radius. Let's say this value is 11.2 centimeter. 11.2 centimeter. Then I will take the arc, center point arc. Then I will, again, where is the center point arc? Take the center point arc and then draw an arc. Again, draw another arc. Select center point arc. Okay, so this is the half portion of the sphere. Then I will join this sphere directly. Then apply the trim command and then finish sketch. Then I will apply the revolve command. Now the sphere is ready. Next, I'm going to calculate the volume of the sphere. What is the equation to calculate the volume of sphere? 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of the sphere, right? So students can calculate by substituting the radius 4 by 3 into pi. Pi is, students can substitute the value of pi as 22 divided by 7 or 3.14 into r. R means the radius of the sphere. Or the students can check in the software, right click body 1, go to properties. When they click the properties, you can see the volume. The volume is 5884.949 centimeter cube. When the students using the equation, what is the equation? Volume of the sphere is equal to 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. He will be getting the same value. So while working with the software, students can calculate the volume manually. Also, they can check the volume of the sphere by checking the properties option in this software. So the last one is the volume of hemisphere. With that, I will stop. So the next one is I'm not creating any hemisphere. The hemisphere is already here. This one, okay. This one is the hemisphere. Go to bodies, right click properties of bodies, click properties. Now you can see the volume. The volume is 19396.193 centimeter cube. So how the students will calculate the volume of hemisphere? What is the equation? So the volume of sphere, what is the volume of sphere? Volume of the sphere is 4 by 3 pi r cube, right? 4 by 3. Volume of the sphere is 4 by 3 pi r cube. If we divide this by 2, that is the half of hemisphere, means half of the sphere, right? So divided by 2 means 2 by 3 pi r cube. So the volume of the hemisphere is 2 by 3 pi r cube. So when we will use this equation, I will get the same value. Volume is equal to 19396.193 centimeter cube. So I'm stopping now. So in this way, the students can use this particular software, because in mathematics, learning math, why we are using this particular software in mathematics? Why this software is called a CAD software, computer aided design. Why we are using this computer aided designing software? What is the use? Because to learn this type of surface area, volume, the students can visually see the shape of the object. They are creating the object. They are designing the object. They are giving the radius. They are giving the slant height. They are giving the height, and they are creating this. They are designing this object. So they are visually dealing with this particular object. So they will learn the concept very easily, because they are visually seeing the object. At the same time, this is really interactive. They are calculating the volume and area manually, and they are checking those values in the software. So this is both at the same time, this is visually interesting, and at the same time, this is interactive also. Students will be easily understand which one is radius. So if when we think about in the mindset of a student, they will be confusing which one is the radius, which one is the height, which one is the slant height, which one is the diameter. So by dealing these objects visually, those confusions will be, we can eliminate those confusions. Student understand which one is radius, which one is diameter, height, slant height very easily. And this is like a hands-on learning exercise. So instead of memorizing formulas, however, formulas are very important. Instead of just simply memorizing the formulas, by implementing this type of learning process, this will encourage the hands-on learning. At the same time, they will not forget the formulas. They will learn the formulas. At the same time, they will understand the concept very clearly. So in this way, we can connect the mathematics into the engineering, design, and industry. And we can build student interest and confidence by incorporating this type of software into their curriculum. So if any students or teachers are interested to implement this software into your curriculum, or if you are planning to implement any type of chapter, okay, if you need any support to use this type of particular software to teach a particular chapter, I'm ready to help. So you can contact me. I will give my contact details below this video, so you can directly contact me. You can send your requirements to my email, or you can directly contact through my mobile number. Okay, so that's all. Thank you very much.